Alrighty guys, let's go ahead and go over this document that we did in class today. So the directions say, read each research question carefully, then identify the independent variable and the dependent variable. Create a hypothesis as the final step. Use the examples in your notebook for help. So the research question was, what effect does smiling have on teachers giving homework? So the thing we are purposely changing, the independent variable, would be the number of times students smile. And the dependent variable, what we're going to measure then, is the amount of homework given. The hypothesis would be if all the students smile at least 10 times a day for the teacher, then the teacher will give less homework. So we are going to add the because onto these as well, because here at West we do an if then because type hypothesis. Alrighty, so let's take a look at this first one. Will a ball roll farther on a wood or tile surface? So the independent variable, what we are purposely going to change between these two experiments would be the type of flooring. So then what are we going to purposely, or what are we going to measure then, would be distance. Because which one will roll further, that will be distance. So now when you write a hypothesis, you have to choose a side. So you would either need to choose wood or you would need to choose tile. I'm going to choose tile. So if I roll a ball on a tile surface, then it will roll farther because the surface is smooth with less friction. Remember, I'm writing a hypothesis here. This is what I think is going to happen. Then I would need to design an experiment and carry out an experiment to see if my hypothesis was indeed correct. Okay, let's take a look at this next one. Will plant growth be affected by the type of light used, like sunlight and house lamp? So what I am purposely changing between these two will be the type of light. What I am going to be measuring is plant growth. So now I'm going to choose a side. I'm either going to choose sunlight or house lamp. I'm going to choose sunlight. If a plant is in sunlight, then it will grow taller because plants need sunlight for photosynthesis. Okay, so that's what I think is going to happen. So I would set up an experiment where I would have one plant in the sunlight, like in the windowsill, and one just under a lamp. Okay, so let's look at our third one that says, when sticky candy is eaten frequently, do more cavities develop? So what is the one thing that we are purposely changing would be the amount of candy, or how often candy is eaten. What am I going to measure then? It would be cavities. Okay, so then I would choose a side. I would choose whether I'm going to eat sticky candy or not eat sticky candy, because the question asks, when sticky candy is eaten frequently, do more cavities develop? So I'm going to choose a side with yes. Eating candy frequently. If sticky candy is eaten frequently, then more cavities will occur because sugar causes cavities. Okay, so I can go through and I can identify my if and my then and my because in all of these hypotheses. So remember, if I do this, then this is going to happen, and my because is my logical explanation. Then because. Okay, so I hope that this helps on this page. We're going to go ahead and continue with this and do a little bit on this page right here. This is something we also did in class today. So we needed to decide whether something was an independent variable, dependent variable, or a control variable. So we're just going to abbreviate those. That's a lot to write, right? The factors that are kept the same in an experiment, those are the things that kept the same. Those are our control variables. The one thing that's intentionally or purposely changed by the scientist would be my independent variable. This is also known as the manipulated variable. The manipulated variable is the independent variable. The factor that is affected as the result of changing the manipulated variable, that will be our dependent variable. There may be many of this type of variable in an experiment. That would be our control variable. This is also known as the responding variable. That is your dependent variable. This variable must be measured to obtain results. What do you measure? You measured your dependent variable. Okay, so what this particular paper looks like is we will look at the question and identify the independent, dependent, and control variables. And if we go and look here, we're going to take two of those questions, then develop a hypothesis and design an experiment. Okay, so let's take a look at this one right here. What amount of fertilizer in the soil produces the tallest flower? So what is it that we are purposely changing here would be the amount of fertilizer. Okay, so that's our independent variable. Then what are we measuring? We're measuring plant height. Really, that's a flower, right? So I should have said flower. So flower height. Okay, so it's fertilizer that we're going to be purposely changing. Okay, so what do we have to keep the same? So we have to have the same soil and the same sunlight. And we have to have the same water. And we have to have the same type of fertilizer. And we have to have the same type of flower. The only thing you can change will be the amount of fertilizer. It's got to be the same fertilizer. All right, let's see if that's one of the ones that we do. Yep, that's this one down here. So let's go ahead and write a hypothesis and design an experiment for this. So what amount of fertilizer in the soil produces the tallest flowers? So I'm thinking that more fertilizer is going to produce tallest flowers, because fertilizer is going to add nutrients to the soil, and I know my nutrients to the soil is going to add food for my plants, and so maybe that's going to produce taller flowers. Okay, so if fertilizer is added to the soil, then the flowers will grow taller sorry about that, guys. Taller because there will be more nutrients in the soil. So, because it talks about what amount of fertilizer, so I would need to decide here how much fertilizer I'm going to add to my soil. Okay, so I'm just going to simply write something like, if 50 grams of fertilizer is added to the soil, then the flowers will grow taller because there will be more nutrients in the soil. So let's design an experiment. Okay. All right, so I would need to have 2 identical plants in the same size pot with the same amount of soil. Label one pot A and add 50 grams of fertilizer. Label the other pot B, how about B, and add 25 grams of fertilizer. Place both pots in the same location and water each plant 5 milliliters each day. Measure the height of each plant in centimeters every 3 days. Record the results. Okay, so I am going to have 2 identical plants in the same size pot with the same amount of soil. Label one pot A and add 50 grams of fertilizer to the soil. Label the other pot B and add 25 grams of fertilizer to the soil. Okay, place both pots in the same location and water each plant 5 milliliters each day. Measure the height of each plant in centimeters every 3 days. Record your results. Okay, so that is how I would set up an experiment. Okay, all right, so let's scroll back up and do one more. Okay, so does the amount of water in the soil increase the amount of bacteria produced? So what is the one thing I'm purposely changing here is going to be the amount of water. And what is it that I'm going to be measuring is going to be the amount of bacteria. Okay, so what do I have to have the same? I am going to have the same soil. I'm going to have to use the same water. Now I am using different amounts, but it has to be the same water. I need to have the same size container, and it needs to be in this under the same conditions. So it needs to have the same sunlight, the same temperature, so same conditions. Okay, so let's scroll through and see if this is the one that we are designing an experiment for, and it sure is. So I am going to say my hypothesis. I'm going to go ahead and type this again. That seemed to work pretty well. Okay, whoops. All right, if I add water to, if I add, like I gotta qualify it. If I add more water to the soil, then more bacteria will be produced, because bacteria needs, let's spell that right, a moist environment to grow. Okay, so that's my if and my then. Whoops, let's make it a then, because hypothesis, this is what I'm kind of thinking. So how am I going to design an experiment? Okay, so what would I do? Okay, so number one, I would have two identical size pots with same amount of soil. Okay, label one pot A and add 50 milliliters of water. Label other pot B and add 10 milliliters of water. Okay, so those amounts that you would be adding, that would be something that you would need to research and determine. I'm just arbitrarily coming up with these particular numbers. So I have two identical sized pots with the same amount of soil. I'm going to label 1A and add 50 milliliters of water, and label the other pot B and add 10 milliliters of water. So I'm going to use the same measuring tool. Yeah. Whoops, sorry about that, guys. Measuring tool to obtain 3 grams of soil to check for bacteria growth every 3 days. Okay, so I'm going to use the same measuring tool to obtain 3 grams of soil to check for bacteria growth every 3 days. Okay, so check both pots every 3 days for 12 days and record bacteria results. Okay. Alrighty, so something along those lines. Alrighty, so that is where we're going to stop today. Simply looking at these two independent and dependent variables, and then looking at what an experiment might look like based on the question. Okay, alrighty, I will see you soon.